All right. Welcome, Robert, and all future people that might be joining the session. I'm Hubert, a developer advocate for StarTree, and today's session or meetup is performance testing Apache Pinot using Gatling. Gatling is a tool for issuing performance tests against an application. And I'll go over the details on that, how it does that specifically. The first thing we want to do is just go into the StarTree examples repository. So if you just go to StarTree Data here in GitHub, and then type examples. You'll see a README that talks about what Apache Pinot is and the types of future examples you would see upcoming. It's a brand new repository, so we're just getting started with a lot of the examples we're going to throw in here. We're kind of scraping the Slack community channel to see what kind of topics and issues people are getting into, and hopefully we could remedy a lot of those with just a GitHub link so that they can do it themselves and debug it themselves as well. The way you use this repository is just you go into each one of these. So each one will be separate from the other. Unless they specify that there's going to be some dependency, but just clone this and you'll be able to go directly to the specific example that you'd like to run. In this case, we're going to performance test Apache Pinot with Gatling. So let's click into there. And every repository in here is going to have a README file with steps to go through the example, as well as a list of tools to install and the overall use case diagram. But in this case, we're using, again, Gatling, which is an open source tool to performance test any application with REST APIs onto them. And of course, Pinot is used behind a lot of the, very popular websites like LinkedIn, or even the phone applications like Uber Eats that serves analytical data to the users that are using those applications. And it's only makes sense to be able to test some of these applications using a tool like Gatling. And I'll go over with you how, again, Gatling works. The first thing we want to do is just go over how this is set up. So we have Pinot set up. We're just going to use a Docker compose or Docker image to run a Quickstart. And this type of Quickstart, this Quickstart comes with a bunch of examples in it. One of his, they call it the type stream. So what this will do is set up this portion of it, the Kafka and the Pinot side of this diagram. And then what we'll do is set up Gatling to stress test Pinot separately. Okay, so by running this Docker run here, you'll set up the environment minus Gatling, and then we'll start up Gatling separately. About the Quickstart, you can actually go into this link here. It talks more about the many other examples that Quickstart has. Some of them are like how to use upsert, how to do a hybrid example. In fact, if you go to the command line, there are tools they could use to actually help with that as well. So if you go to if you have the Pinot admin command line, you'll see that it has a lot of things that you could do to interact with Pinot. Let me just move this out of the side. I don't know if I can just take this away. There you go. Just list them. You can add a table. There is also a quick start, and this is what we'll use here. But there's a lot of administrative tasks you could use to to run using the Pinot command line, Pinot admin command line. So a quick start. And let's do another -help on that. And then you'll see it has expecting a type, which is a dash type. And these are the options you can give it here. What we're going to run is, can't find it in here, but it's titled stream, which is this one. Okay. I have this running already in the background. All I did was just started up here, and he's running in the background. If this is running already for you, you just go straight to the Pinot Console, which is localhost 9000, and here's your cluster in Pinot running in a single node. And here are the tables that are set up. These are the Meetup RSVP and the airline stats are continually running. So if you were to just refresh this, you'll see these numbers get bigger. Alternatively, you can go to the query console and click on airline stats. You'll see that it's got a limit of 10, but if you keep running this here, you'll see that number grow each time. So there are data coming through from a mocked Kafka cluster in the same instance. So what this does, this quick start will start the Kafka and a Pinot, and then it'll start putting this data from Kafka into Pinot, and Pinot is pre-configured with a set of tables in it, real-time tables, so that you could start playing with it. In fact, there's a list of things that this command does. It starts up a Kafka, a zookeeper, a Pinot controller, broker, and a server, and then creates what we'll be using, an airline stats table, along with some other tables if you'd like, but also it launches a stream that's writing data into Kafka, and then Pinot is reading that topic from Kafka and loading the airline stats table. Okay. So we are now to the point where we're looking at the console, and we're able to read and query data from the in our case, the airline stats table. Okay. From there, we're just going to test out this endpoint. So we are testing REST endpoints. So you should be able to curl this. This is an unsecure Pinot cluster. It's a quick start. So there'll be more parameters here if you're going to run it securely. But this is what we have right now. This is what we're going to do. We're just going to run this command. As you see, it came back with some results. I believe it's the same query, limit 10 of airline, or a limit 100 of airline stats. As you can see, it returned some data. This also passes it to JQ, which is a way to beautify the JSON result that comes back. Again, that's on the list of things to install with jQuery or JQ. Excellent. We're almost to the part where we are going to learn about Gatling. So what is Gatling? It is an open source tool. You could go to it here. It's a way to run a scenario or situations where you would that could happen in your application, and then invoke those REST calls and actually mimic many users, even thousands or hundreds of thousands of people hitting your in this case Apache Pinot or your web application. Okay. So let's get going. The first thing we want to do, there are two ways we're going to run Gatling. First, we're going to use Scala as a way to kind of define the stress test and the scenario, and use a they use Gatling's SBT plugin. SBT is a Scala build tool. Just like a Maven build tool, you would use that tool to run on the command line. But either way, Maven or SBT is it'll be basically the same thing. And then Gatling provides these plugins to you. You can have them in Maven and Gradle and others as well. So definitely look at their documentation and learn some of those other ones. We'll be using again Scala. Scala is a bit less verbose, so it makes for easier code to look at and learn. You should be able to translate these codes to the specific language you would like to use. And then the second way we're going to do is the Gatling Bundle. The bundle is something you would download and explode locally on your disk, and then run a command that will test that, as opposed to using SBT, which is specific for Scala. So this would be in case you're not using Scala and you want to use a more generic tool for testing your application via Gatling. Okay. So let's do this really quickly. Let's grab the git clone command here. We're going to actually go to a different directory and go in here, and then let's clone that directory and put it in here. If we look at that directory, you'll see it's basically this over here. Sorry, there's some tools I have to move around. This is what you get. This is the code we're going to modify in order to begin the tests. So if we navigate to that place, let's just use our handy dandy VS Code. Open that here. And go to the source. And here's our code. It's already coded for you, but this isn't the code that we want to run. We want to run specifically what we want to do as far as running tests. So I'm going to switch back to the browser because the browser's text is a little bigger. And this is the code that we're going to use. And let me just walk through what this is doing here. So this is an HTTP. We've named it select. So when Gatling generates the report, it'll use some of these names that you give it to help organize and visualize the results, the performance results. We're going to do a post. In this case, we're going to post to the SQL endpoint, which is what we should do anyway, right? This is how we invoke queries via REST API to Pinot. It's not secure, so the only thing we need right now is the content type of JSON, and then the body is a SQL JSON. So this is not the but this is a more specific SQL, which is this one down here. But this is the SQL we would like to run. Notice if you look it down here, there's a cancellation code, the average delay, and then from that table where the air time is greater than, I believe, 100 hours. And then we group by cancellation code. Basically what we're asking here is like, what we're asking here is to get the average delay per cancellation code, that's where the air time is greater than 100 hours. And we're basically trying to figure out, what are the cancellation codes typically happening when there's a delay. All right. So that's this part. So we've all assigned that to H here, which is, our kind of like request basically to Apache Pinot. So this is all going to Apache Pinot. You can create many of these. They all don't have to go to Apache Pinot. Technically, really, the way you would do this, if you have an existing application, this will go to different REST point APIs. And in the backend, those may call Pinot themselves, or some of them may not. But it all depends on what your application is doing. Here, we don't have an application. We're just using Pinot directly. So we could just build the scenario up as we know it, and then we send that over to Pinot. For instance, I will probably name this step 1 in the process, where I click on a view and I see a list of cancellation codes and their delays. And then if I wanted to drill down any one of those cancellation codes, then I could bring that up. I could create another SQL statement and create yet another H here named, cancellation code. And I would have yet another H to add to one of the list of things I want to call against Pinot. Right here, this is where you build a scenario. A scenario meaning, like, if I were to visit your application, and the first step would be to invoke this in the back end, and then another SQL in the back end, and so on and so forth, right? So in this scenario, we have named it select, and then we're going to execute H, and then we're going to pause for a second, and then execute H again, and H being this code down here. So when we're creating a scenario, we're doing it from a perspective of just one user. Like, if I were just one user, what would be a typical experience of me navigating through your application? What are those endpoints? What are those SQL statements in our case? And that's what would be your scenario, and that's represented as S, right? So you can build up many scenarios if you'd like, but this is a very simple one. A list of a set of SQL statements, and that's embedded into a set of a scenario. And notice that the SQL statement is being executed multiple times. H could be a different one, as I said, depending on what the user here is supposed to do in your application, right? So now that we have a set of SQL statements to run, here we only have one, and we've built a scenario, we just set it up as this way. So we take that scenario and we inject and simulate 100 users, right? So you can make this 1,000, depending on what you think the capacity of your application can support. Pinot is really powerful, and this is why we want to do this for Pinot, so that you can actually test for yourself how well or how fast, compared to the other solutions that you're using, Pinot is serving these analytical queries in your applications and ultimately to your end users, right? Here, this is the same thing. This is where we actually define the JSON request to invoke the SQL statement. Let's do that. So I'm going to grab this code. I'm going into Scala and just paste it, and then I'm done. All right. This automatically is going to my local Apache Pinot instance against my Quickstart streaming application. So all we need to do is go to that directory, which is here, and run SBT. Let me just make sure I have the right command here. So here's SBT. There's a specific command that you would have to call, or a plugin. This is the plugin you need to call, and instructing SBT to run the Gatling test using this command. So copy that. And I have SBT already installed. There it is. Oh, it's which. I always do that. Okay. So let's run it. So it's going through some, it's actually building itself up first, and then here it's starting to, it should be down in the bottom where it starts to run the scenarios. So completed, or compilation is successful. And there are the requests. So we're simulating 100 users, right? So you're going to see at least 200 requests, right? Because each scenario invokes that SQL statement twice. So you're simulating 100 users calling this statement twice with 1 second in between them. That's what just happened. So if you look down here, you'll see that there are 200 invocations from that scenario, right? And this is actually a decent report. It spits out a report for you directly, right? It gives you a 95th percentile, the percentiles and the min and the max, standard deviation, the basic, measures of centrality for your statistics for your performance of your endpoint or your application or your actually scenario. But that's not really a pretty thing to see. The way you do is when you grab this file, and Gatling's actually created you a nice report, so you can just open this, and there you are. Right? I have a few things running on here, so this is not going to be very accurate, but you'll see that some of the time ranges under 800 milliseconds. Here's some outliers. Response, you can kind of see two sets of requests. The first ones that creates a burst, the wait a second, and then the second burst of requests. You can create a longer simulation. Extend the second to like 5 seconds and then invoke many other different SQL statements that kind of mimics what's happening on the application. All right. So that's it for the SBT version, right? So how do we do this let's say you weren't using, Scala and you wanted to use the bundle, which is another, command line tool. Let's do that down here using the bundle. So we have, let's see, the bundle is already here. So let's go get it here. And then you could download using the bundle. I have the bundle already in here somewhere. Let's see. Gatling. No, that's not there. We have to go get it. So let's download. Here's the source. So let's download the bundle. So there's our bundle, which is Gatling charts. So let's go back to our command line. And let's move that, or in our directory, and there it is. So let's Gatling charts. There we are. And so if we look at the tree here, it's a bit, it's bigger because you have the entire library here of Gatling. But what we want to do is run this Gatling test here. So if you're in Windows, obviously you'll run the BAT version, but we're on Mac, we'll run this one. But again, what we want to do is replace the simulation with our own, okay? And we can just do that by copying what we've done in the other one. So cp / source, and we're going to put it here. So we have a basic simulation test. This is our test that we did with our SBT. We're actually going to put it in the user files, simulations, and computer database. So let's move that into user files, simulations, there. Okay. So there it is. So we have actually two tests, but this one is their own, the test that it comes with. This is the one that we've just copied over from our SBT version. The same code as we saw here that tests this endpoint, this SQL statement in this scenario with 100 users. All right. So here, this is a lot easier actually. All we need to do is go into the bin directory and run the Gatling script. So bin Gatling sh. It'll ask you a few questions here, so I'm going to use to run it locally. And then I want, if you recall, we had two tests in there. We want to do the one that we just added, so we want 0. Oh, just 1. Again, I did the same thing. Notice 200 requests and basically the same report. There we are. It looks like Pinot cleaned up itself. It's running a lot faster. No outliers this time. It's the same Pinot instance, right? We ran Gatling 2 different ways. One from SBT. This time we ran it via the bundle. Okay. And from here, as your reports indicate, bad performance, what you'll need to decide, what can I do to improve, what kind of indexes or what kind of optimizations can I add to Pinot in order for these queries to run more performant, right? And that's the beauty of Apache Pinot, is that you can go in and better tune these using built-in indexes. So what you would do typically here, since we are doing a what is that query? We're doing an aggregation. You might be able to add a range index on the airtime field, which I'll do in a different video actually. But you can add those indexes in a index config, and this doesn't even have any optimizations with indexes. So we could actually add lots of performance enhancements to this table so that it's more performant when querying those specific query statements against Pinot. And that's it. You could download this or clone this repository, run these same simulations, create your own scenarios to your own data, mimic some of the behaviors that your users will have when navigating through your application, and see how well it performs. And then subsequently find out how you could better tune some of the Pinot to be able to return some of these results a lot faster. You can get started with the links in the summary section of this repository, way to download Apache Pinot, as well as upstairs here, where to download the open source Gatling Bundle yourself.